Hello everyone, we're from Group A going to talk about the Charles Law experiment. Before we continue, let me introduce myself. My name is Simon Davis, Nairobi. My matrix number is 76889. Ramin Zakrin bin Zulkifli 74185 and Sonia Robin 76877. Do you know the first law of thermodynamics? Okay, it states that when the energy is cannot be created nor be destroyed. Energy can transfer from one form to another. The triangle signifies the changes in quantities enclosed in parentheses. The system may change in its internal energy, in its potential energy or kinetic energy, and in potential energy or kinetic energy of its finite parts. Do you know what's a Charles law? Charles law stated that the volume occupied by a fixed amount of gas is directly proportional to its absolute temperature when the pressure remains constant. V varies with T, which means V varies with T. In this experiment, we're going to do an experiment on the balloon will be kept in a bowl for a short period of time, whether in the hot water or cold water at different conditions. From there, we want to determine the diameter of the balloon when it immersed in the bowl, and the time taken will be taken when the balloon will be expanded or deflated. The objective of this experiment is to study the changes of volume taken at the different room temperature, to study the effect of the sizes of the balloon changes when immersed in the ball, and to study the relationship between the temperature and volume of the gas. The variable of the experiment is, for the manipulated variables, the temperature of the liquid. The corresponding variables is the size of the balloon, or we can say the diameter of a balloon, and the constant variables will be the volume of liquid. The hypothesis for this experiment is the diameter of the balloon increase, the volume of the balloon also increase, and as the time taken for the balloon to increase, the size of the balloon in the ball also increase.
Next, for material and apparatus, we will be needing a ball or a basin or a container, an ice, hot water, thermometer, balloon, and measuring tape or string and ruler. Next, methodology. For sampling procedure, the first step, the balloon was blown and its initial circumference was measured. For second step, the balloon was immersed in a bowl of hot water for 1 minute and its circumference was measured. For the third step, the balloon then was immersed in a bowl of ice water for 1 minute and its circumference was measured. For the final step, step 1 until 3 were repeated with different time interval, which are 2 and 3 minutes. As for general startup procedure, the first step, the water was boiled. The second step, the balloon was blown and its initial circumference was measured. As for its experimental procedure, the first step, the balloon was immersed in hot water for a minute, then its circumference was measured by using string or measuring tape. As for its second step, the balloon was immersed in iced water for a minute, then its circumference was measured. For the third step, step 1 until 2 were repeated with different time interval, which are 2 and 3 minutes. As for its general shutdown procedure, the water used was made sure to be poured into the drain. Lastly, for its safety and precaution, first, the hot water was made sure to be poured carefully to avoid it from spilling. And second, cloth or glove was used when immersing the balloon in the hot water.
Okay, hello everyone. My name is Armin Zakrin bin Zulkifli, matrix ID 74185. Okay, today's I'm gonna continue my part, that is the result of the experiment. So from the given in the slide shown is our result from our experiment. Okay, as you can see, from the experiment from running test 1, here we got to measure our on the sizing balloon first. Here from the initial circumference we got 30 centimeter for our first initial circumference of the sizing balloon when we blow up the balloon first. Then we prepare up the temperature hot water and cold water for our experiment. Here we taken up the temperature for the hot water and the cold water. For the hot water is 68.4, but for the cold water is 1.8. The time taken for our running experiment is in 1 minute. After the balloon been blow up, and then we measure up, and then we put inside the hot water first, and then we wait until 1 minute. After 1 minute, we take it out, and then we measure the circumference. So we measure up, we got 30.3 centimeter. So after that, we immerse back into the cold water. So the cold water, we wait another 1 minute too. After 1 minute, we measure up the result for the circumference. We got 29.7. After that, we do the percentage error. Then we got 2.23%. But for the percentage error, we're using the theoretical along with the experimental, so we can identify our differences between our own theoretical with the experimental. So we got 2.23%. Therefore, for the running test 2, being also the same, we're using the same initial circumference sizing is 30 centimeter, but the different temperature we taken. So the temperature taken we already be taken is 78.4 degrees Celsius. But for the cold water is 2.4. But the time taken, every time taken for our running experiment will be added in 1 minute. So our time taken will be 2 minutes. So after it been running, using the same method, immerse in the hot water and then taken up the measurement. So our measurement after it been hot is 30.6, and then in the cold water immerse also, we got the measurement and it is shrunk, become 39.2 centimeter. Therefore, our percentage error for this running test is 0.41%. So the percentage error is decreasing. Next, for the running test 3, still the same, using the same method, only the different temperature taken. So the temperature taken for the test 3 is 68.1. For the cold water is 1.6. After it been immersed for the hot water and the cold water, then we added it is running in 3 minutes. So the percentage error is increasing back into 1.82%. So this impact, if the temperature is decreased, the pressure and the mass is constant, the volume will be decreased. But if the volume and the temperature, therefore that's why the volume and the temperature is directly proportional, which means if the volume decrease, temperature also decrease. So this for the result explanation part. Thank you. Next. Okay. For the next part, for the discussion, after we get all the result and the data result, after all data result be taken, after the value of the percentage becomes slightly decreasing when the time taken is when the time taken for the shrink of the balloon is longer. Well, this is due to assume the shape of the balloon is a sphere where the elasticity of the rubber changes due to the temperature surrounding, where there is hot where as the hot water as the hot temperature and cold temperature enter to the balloon. So that is why there is a changing effect between the elasticity of the balloon as the number of the impact of air molecules enter in a balloon are decreasing with the lower temperature. Thus, the the less energy is going outside surface of the balloon, so the balloon contracts and become smaller. So that is our discussion part. So thank you.
In conclusion, the volume of a fixed mass of a gas is directly proportional to its absolute temperature at a fixed pressure. When the temperature of a gas is increased, its molecule gain kinetic energy and move faster. This increased threat of collision with walls of the container, and hence it will increase the pressure. However, since in Charles' law, pressure must be constant, the volume of the container must be increased accordingly so that the gas molecule can cover larger distance before colliding with the walls of the container. This would keep the gas pressure constant although its temperature is raised. Thank you everyone for listening.